One of the major enablers of new digital products and business models for the digital transformation of enterprises is flexibility and adaptability to changes. In this video, we will explore how the iX model supports the digital transformation of companies by providing a highly flexible and multi-purpose connection as the core for strong and secure digital infrastructure. Digital transformation is about implementing change through technology, analyzing and understanding the value of that transformation, recognizing and grasping new opportunities, and thus becoming more competitive. Flexibility is increasingly demanded by companies. They require the means to redesign the company connectivity for each of their locations and operations in line with their ongoing transformation process. Connectivity used to be an enabler, but as new products are developed and portfolios evolve in modern digital business, it is often becoming an intrinsic part of the product. The connected vehicle is an excellent example of a product with embedded connectivity. Therefore, enterprises are demanding greater flexibility in all aspects of network performance, bandwidth adjustments, latency optimization, improved security, and reinforcement of the resilience of the connections, not to mention time-independent booking and adjustment of services and intelligent automation. We will talk about these benefits in a coming video. Here, we will focus on the impact they have on digital transformation. So how is the enterprise connectivity landscapes evolving? A digitally transformed industry will have much more demand for data storage and processing than a traditional business. The use of cloud technologies here is a must for most companies in their digitalization process. The adoption of services from different providers opens a broad set of scenarios such as cloud services, software as a service or SaaS, platform as a service or PaaS, and the use of multiple data centers in a distributed array, for example. In all of these scenarios, the flow of data content becomes increasingly complex. Take into consideration how these services connect to customers and users. Probably spread across different locations further increases that complexity. These scenarios make it difficult for a company to have a complete control over the communications and over the data exchanged. For example, often the connection to cloud services will go over the public internet, with all the risk that this involves. This issue is quite common in any digital transformation for medium and large companies with a global presence. As a result, organizations have an increased demand for aggregating and transporting data. But beyond this, an industry is no longer the preserve of the manufacturing plant alone. The increasing use of advanced manufacturing technologies based on services, such as robotics as a service, involve intelligent machines being owned and operated remotely by external partners. This example illustrates the general trend and need to optimize the company connectivity, not only to headquarters, branches, data centers, and production plants, but also to specific external providers. Intelligent production processes, be that the use of robots, smart quality assurance, or additive manufacturing, example, 3D printing techniques, place much greater demands on the resilience of the connectivity. This requires guarantees in the form of high-level service-level agreements with dedicated bandwidth and lower latency, along with flexibility.
Another common trend is the consumption of more services from centralized cloud. Indeed, from multiple cloud providers simultaneously as part of a company's multi-cloud or hybrid cloud strategy. Here, end-to-end flexibility again is required to guarantee the bandwidth that is actually needed for the given service. Companies today no longer think in terms of the historical A to B locational conception of connectivity. Instead, they require more fine-grained connectivity between applications, services, workloads, devices, and users. The conception of connectivity is no longer about connecting sites in, for example, two particular cities. Rather, the focus is on goals like setting up connectivity between the company's artificial intelligence cluster in a centralized server farm and the locally hosted traditional SQL databases. The design of these interconnection services therefore needs to be approached in two ways. Firstly, by creating a robust, secure, resilient, and high-performance physical infrastructure. And secondly, by adding flexibility and simplicity through virtualization and automation, thus enabling a range of customizable services. Resilience is essential for keeping data traffic safe and flowing. As we have seen in the previous examples, in any digital business, the trust in its connectivity infrastructure is essential. Daily operations require the transportation of massive amounts of data, be that customer data, maintenance of systems, analytics, and any other of a myriad of essential data-driven use cases. In the real world, incidents and outages happen all too often. And it is necessary to build a strong and resilient connectivity in such a way as to minimize the impact of those disks. Through building multiple layers of redundancy in terms of technology, geographical distribution, and also connectivity, any company can design its critical digital infrastructure to more immune and resilient to real-world events.
The role of Internet exchanges, explained in the first module of this course, provides an efficient solution to the challenges of digital transformation. For example, redundancy, neutrality, and diversity in digital infrastructures are key to the greatest level of resilience. This must be factored into the design of enterprise connectivity from top to bottom. IX platforms may provide the physical redundancy necessary to support and guarantee the service level agreements to customers. The distributed nature of some IX platforms allows access from multiple geographically dispersed data centers, and together with redundant deployments, this ensures resilience against localized outages. A resilient design of an IX platform includes as diverse connectivity as possible, with redundant data pathways taking different non-overlapping routes, so that even in the case of localized outages along one pathway, connectivity can still be maintained between locations. Also, the global interconnection of data centers needs to be balanced the network capacities across different submarine cable routes, increasing the level of resilience in all connections. Strong IXs and their interconnection ecosystems are key locations where it is possible to find all the digital service providers that the business world needs to access to. The data centers, the network operators, the cloud, and content providers, the content distribution networks, and other stakeholders. To sum up, IXs fulfill the interconnection needs of enterprises along their digital transformation process using technology and provider-neutral integration.